Hello, algebra class. I know you want to kill me after the last assignment because completing the square can be very, very difficult, and it's not something that's all that enjoyable. But completing the square helps us because our solution set ends up telling us where the parabola crosses the x-axis. And that's what we're looking for. We're looking for roots. And here is another lesson. It's called the quadratic formula. We're going to talk about the discriminant. And the quadratic formula is another way to find those roots of that quadratic equation, or where that parabola crosses the x-axis. So we first and foremost always put our quadratic into this form, this ax squared plus bx plus c. So we're really getting used to seeing this, ax squared plus bx plus c, and we know what a, b, and c are, and we're gonna need them a lot because look at that. Oh, isn't that beautiful? That's a thing of beauty, right? The quadratic formula tells us those x values, where it crosses the x-axis, is negative b plus or minus the square root of b squared minus 4ac all divided by 2a. You can see it, and I say it. I've said it a couple of times, but I want you to look at this. Wait a minute. Haven't we seen negative b oh, that's a horrible way of doing that. Haven't we seen negative b divided by 2a before? Where did we see that? Oh, yeah. Vertex. Oh my gosh. It told us where the midpoint was in our parabola. So the cool thing about this is that within this formula, there's the piece that tells us where our parabola is centered. And then there's another piece that tells us about what types of roots there will be. And that's what we're going to talk about. What's underneath this what's underneath this square root symbol, this radical, that's called the discriminant, that b squared minus 4ac. And we'll get to that in a minute. Step one, when we want to solve using the quadratic formula, we have to take this original, right, x squared minus 5x equals 14, and rewrite it in this form up here. So that's what they did, x squared minus 5x, and they subtracted 14 from both sides so we can get this equaling 0. And now we have an a, we have a b, and we have a c. And so we say that a is 1, and b is negative 5, and c is negative 14. Whoa, I can't write. Anyway, and then you just put all this stuff into this nonsensical, this annoying piece of trash that you guys are going to hate so much. But if you can get used to this and you can use your calculators to solve this, then you're going to have a really easy time. And what we do is we put all this information in, and we get 5 plus or minus the square root of 81 divided by 2. Well, we have plus or minus here. Remember, we can use a positive, we can get out a positive 9 or a negative 9, right? Because negative 9 squared is 81 and positive 9 squared is 81. So we have to solve for both of those values. And it doesn't write it here. This is basically 5 plus 9 divided by 2 and 5 minus 9 divided by 2. And then they come up with negative 2, which is this one, right? 5 minus 9 is negative 4. Negative 4 divided by 2 is negative 2. And then 5 plus 9 is 14. 14 divided by 2 is 7. Okay, and so that's basically what you do. Okay? And so now we're going to try one. Are you ready? We're actually going to try two. Here's our first one. Or not. There it is. Hello, friend. Now, we're lucky because this is already in ax squared plus bx plus c equals 0 form. All right, so we have what we need. We see that a, the coefficient in front of the x squared term, is 1. We have b, which equals 10. And we have c that equals 24. Oh, my God. Okay, here we go. The quadratic formula is negative b plus or minus the square root of b squared minus 4 times a times c. All right, here we go. All of this is divided by 2 times a. Right? We have what we use to find the vertex, and we use the discriminant, and there we go. All right, so let's start inputting values. Negative b, and I guess I should have used different colors, but I didn't, but it's okay. Negative 10 plus or minus the square root of 10 squared minus 4 times 1 times 24, right? Because a is 1 and c is 24. And all of this is divided by 2 times 1. Now over here I'm going to start doing some of the work because I want to be able to show you my answer down below. Actually, I lied to you. Sorry about lying to you. Let's do some of this work. So we have negative 10 plus or minus square root of 10 squared, which is 100, minus, what is that, 80, 92? Isn't that right? 96, sorry, 96. Minus 96. 4 times 24. 4 times 4 is 80. 4 times 2 is 80. 4 times 20 is 80. And 4 times 4 is 16. 80 plus 16 is 96. Yeah, we did it right. Wow, I must be getting tired. And then 2 times 1 is 2. All right, so we do that 100 minus 96 and we get 4. So let's move it way up here. So we have negative 10 plus or minus the square root of 100 minus 96 is 4 all over 2. Okay, so we take the square root of 4. So we have negative 10 plus or minus 2 all over 2. Ready? We're going to solve both. Negative 10 plus 2 divided by 2 and negative 10 minus 2 divided by 2. All right? Negative 10 plus 2 is negative 8 divided by 2, which equals negative 4. And then negative 10 minus 2 is negative 12 divided by 2, which is negative 6. So we have 2 real roots of negative 6 and negative 4. Pretty easy, right? So let's get rid of that. Let's bring up the next one. Oh, no, we have an A. Just kidding. Here we go. Do the same thing. It's already in that form. I didn't have to move the 15 over or anything like that. So I'm going to use different colors. A is 2. There's a coefficient in front of that square term. B, in this case, is 1. And C is negative 15. This is going to be very, very important when we get there. Don't you fret. Okay. Here we go. Are you scared? Let me write out the quadratic formula again. It's negative b plus or minus the square root b squared minus 4ac divided by 2a. Got it? Okay, here we go. I'm scared. So, negative b, I have to use my green. So, negative 1. Go back here. Plus or minus the square root of, what's b? b is 1 squared minus 4 times 2, and then was that orange, times negative 15. Uh-oh. Okay. So, all of this is over 2. Whoops. Sorry about that. Times 2. Doesn't look like we're going to have a perfect square in here, does it? Well, I guess we're going to have to figure out how that's going to work. If I have a calculator handy, I'm going to need it. Perfect. I knew what it was, and I second-guessed myself. Well, the 1 is easy. The 1 squared is easy. So here we go. So we now have, and I'm just going to write it all in one color now. So let's start doing our math. Negative 1 plus or minus the square root of 1 plus 120. That's 120, by the way. Minus a negative is plus a positive, so it's going to be 121. And it's going to be all over 4. Okay? And I made that way too big. Hey, stick with me, kid. There we go. Pretty. Okay, so let's move on. Let's square root of 121. Hey, wait a minute. That is a perfect square. 121. We like 121. That's 11. Okay, so let's start rewriting it up here. Negative 1 plus or minus 11 divided by 4. Go figure. So it's also going to be, negative 1 plus or minus, nuts and bolts. There we go. So we have negative 1 plus 11 divided by 4 and negative 1 minus 11. Oops. Sorry about that. It's negative 1, dummy. Minus 11 divided by 4. Sorry about that. Negative 1 plus 11 is 10. So that's positive 10 divided by 4. We can simplify this 5 halves if we want. 5 halves, or 2.5. You guys love your decimals. All right. Now we have -1 minus 11 divided by 4, which is -12. Sorry, yeah. -12 divided by 4, and that is equal to -3. And that's it. All right. So now you know how to use the quadratic formula. And sometimes you'll have answers with a plus or minus square root answer, and it won't be something that you can simplify. If by chance this was not a perfect square, say it was 120, you could leave your answer as, let me just show you. If, and this is a big if, kids. If, let me get rid of that. If this was actually 120. I know we could factor something out of it. I know that there's, I don't know, there's a 4 in there. 4 and a 30 and, yeah, so. Let's see, 120 divided by 16, right? Nope. Okay, so no. Anyway, you could leave this as an answer if you don't know how to simplify this square root. It's okay to leave this answer as a final answer. Okay, even with the plus and minus right there, I'm okay with that. So I want to move on. I'll talk more about this later. I'll talk about this when we get into class tomorrow. Let's move on. Oh my God, the discriminant. And that's that piece that I was talking to you about. Sorry, I didn't mean to do that. That's that piece that we were talking about that said, b squared minus 4ac, and it tells you basically one thing. It tells you how many and what types of roots there are. Do we have rational roots? Do we have irrational roots? Or do we have complex roots? Roots that aren't real. And what that means is, in your three-dimensional idea of life, or your complex roots, sometimes your parabola, sometimes that parabola does not cross the x-axis, and then we have irrational roots. Well, sometimes it doesn't even exist on here. It doesn't look like this. It doesn't touch anything, and then it touches our complex roots. So that's what that's talking about. So when you figure out what the discriminant is, you can use the idea of this. And I'm going to flip back and forth for us to see it when I do the math, because I think I accidentally put this in front of what I needed to do. All right, so here we go, and I'm on this layer here, right? And so all I need to do is use the discriminant, which is, remember, b squared minus 4ac, and then we figure out what it is, right? Well, step number 1 is put this, like I said, put this in the right form, ax squared plus bx plus c equals 0. We need to put that in that form. We know that number 2 is already in that form, but let's set up number 1 to be in that form. And what we're going to do is we're going to add 4 to both sides. So it's going to be p squared plus 12p plus 4 equals 0. Now we know our b is 12. Now we know that our c is 4, and we know that our a is 1. So b squared, 12 squared minus 4 times a, which is 1, times c, which is 4, right? And that's going to be equal to something. Well, let's see what it is. It's 144, that's 12 squared, minus 4 times 4, which is 16. 144 minus 16 is going to give me 128. Well, does that work for us? Well, let's find out. Is this, I'm going to take this away for a second. If that number is greater than 0, 128 is definitely greater than 0, and a perfect square. Is 128 a perfect square? No. Okay? But it is greater than 0. So it does have two roots, but they're irrational roots. It means they have non-terminating, non-repeating decimals. And that's basically the idea here. So what we're doing is, hey, here's our 128. And we could simplify this, I think. There might be something in there. 128 divided by 4. Let's see. Yeah. So there's definitely, oh, wow. Two. Okay. So I could. There are some square roots in there that I could factor out. But I know that this 128 is not a perfect square, so I know it has two irrational roots. And I don't really want to go on farther than that. All right, so let's do the next one, and we'll use this color here. Why not? A, B, and C. All right, so negative 6 squared, right? Minus 4 times 9 times 1. Okay, here we go. This is going to be an interesting idea. Look at this. 6 times 6 is 36, right? So that's 36. Wait a minute. Minus 4 times 9, isn't that 36 as well? Huh. So it equals 0. Oh, well, what happens if it equals 0? So, well, I'm going to close this up for just 1 second. And let's say, if the discriminant equals 0, then it has one rational root. Right, so then I go back here, I open this back up, and I say 1 rational root. And then you can, put the, pardon me, you can put all this information in and use the quadratic formula and find those roots, but just using the discriminant to tell us, describe the number and types of roots, great. Then use the quadratic formula. So there will be a lot of homework assigned with this. It's just plugging and chugging. I'm going to cut it down. I'm probably going to say, only do column 1 on side A and column 1, maybe column 2 on side B. But, this is pretty important. The quadratic formula is so important and is used forever and ever and ever.